Hello, grade 11s. Welcome to your first chapter of mathematics, exponents and sets. In this video, we are going to cover a revision on exponents. If you are doing grade 10, you can also watch this video as it will be helpful to you too. Let's say, for example, we have the following problem. Let's say we have a, b squared, c cubed, all raised to the power of 0. Remember, in grade 10, we have learned that we have laws of exponents. And the first law stated that any number raised to the power of 0, that number is equivalent to 1. So in this case, if you look at our expression here, everything is raised to the power of 0. Therefore, we don't have to think about this problem. We just know if anything is raised to the power of 0, the answer will be 1. You need to be careful. Sometimes you will be given a number and then something that is raised to the power of 0 is inside the bracket. So now the answer to this problem is not going to be 1 because this 2 here is not raised to the power of 0. So to simplify a problem like this, you're going to say, okay, we know that anything raised to the power of 0 is just going to be 1. But now this 2 is not raised to the power of 0, so we're just going to write it as it is, and then we multiply with the answer of this thing that is raised to the power of 0, and the answer is 1. So therefore, the answer to this problem is just going to be 2. So that is the first law we have learned in grade 10, that any number raised to the power of 0 is equivalent to 1. So now let us look at the second problem, whereby we have 1 over x y to the power of 3 all raised to the power of 2. So remember, if we have an exponent outside the bracket, this exponent outside the bracket is going to multiply with the exponent of everything inside the bracket. So now, if a number is not raised to any exponent, that number has an exponent of 1. So this exponent outside is going to multiply with the exponent of this number, which is 1, and the exponent of x, and also the exponent of 3. So now the answer to this problem is just going to be 1 to the power of 2, and then x to the power of 2, and then y to the power of 6. Remember, this 2 will multiply with that 3 there. So that is why we have everything that we have. So now 1 raised to the power of any number is just going to be 1. So we know this is going to be 1 over x squared y to the power of 6. So with this law of exponent, whereby the exponent outside the bracket can multiply with the exponent of anything inside the bracket, it only applies if what we have inside the bracket is just one term. For example, what I mean is that it is a product. So it can be a multiplication between two numbers or a division between two numbers. But now, if we have a plus or minus between the numbers inside the bracket, so the law of multiplying the exponent, this is not going to be applicable. It's going to be incorrect because the law only applies if you have multiplication and division. But in this case, if you have a plus or minus, remember this exponent to 2 means that this thing will multiply itself 2 times. So therefore, you are going to have a plus b multiplied by a plus b. So this happens if you have what? A plus or a minus between the terms inside the brackets. So now, let's move on to the next example. Let's say now we have x to the power of 2, y, z to the power of negative 1, all raised to the power of 3, multiplied with x to the power of 4, y, z to the power of 3, all raised to the power of negative 1. So now, when we simplify this following problem, we are going to apply the law that we talked about in the previous problem. So remember, whatever that is outside the bracket and then it's an exponent, it will multiply with the exponent of everything inside the bracket. But we also know that if a number or a variable is not raised to an exponent, therefore the exponent of that is 1. So now in this case, the 3 will multiply with the exponent of 2 and will multiply with that 1 and that 1. So this first bracket will just simplify to become what? To become x, and then 2 multiplied by 3, that's going to be 6. And then we have y to the power of 3. We have z to the power of negative 3, because negative 1 by 3 is negative 3. So you're going to do the very same thing here to this problem. This negative 1 will multiply with that, and multiply with that. So we are going to say that, okay? So now, the first one is just going to be x to the power of negative 4, because 4 multiplied by negative 1 is just negative 4. And then we have y to the power of negative 1. We have z to the power of negative 3. So that is the law we have discussed in the previous problem. The exponent outside the bracket multiplies with the exponent of everything inside the bracket. Consider what is inside the bracket is a multiplication or a division. So in this case, we just have multiplications between the terms. So now, after we have done that first step, we are going to consider the law of exponent that says that if ever you multiply numbers with the same basis, you keep the base the same and you add the exponent. So now you must be careful if you are multiplying and then you have the same basis, that means you're going to add the exponent. So now we're going to keep the base of x the same. So this is just going to be x, and therefore you're going to have 6 plus negative 4. So 6 plus negative 4, that is going to be equivalent to 2. And therefore, you will move to the second variable to check now if you have this variable multiplying with the same variable again. So we have y multiplying with y there. So this is going to be 3 plus negative 1. So this is going to be y. And therefore, 3 plus negative 1 is just going to be 2 also. And therefore, the very same thing will be done for z. So you're going to say we have z there, but now we're going to have negative 3 plus negative 3. So negative 3 plus negative 3, that is going to give us negative 6. So this will be the answer to the problem. So now when you multiply the numbers like this, you make sure that you multiply variables that are the same by adding the exponent and keeping the base the same. So that was another law we have learned in grade 10. So now, as we move on to the next problem, it is whereby we have 1 over x y squared all raised to the power of negative 2 multiplied with x cubed all over y squared raised to the power of negative 1. So now, in this problem, what we can clearly see is that the exponent of our expressions is negative. So now, if we have a negative exponent, we don't actually like negative exponents. So what we do is that we convert them to be positive exponents. So what do I mean? Let's say, for example, if we have a over b all raised to the power of negative 2. To change this exponent to be positive, what we do is that we just change what is on top of the fraction to come at the bottom and what is at the bottom to come at the top. So now we're just going to say this thing is the same thing as b over a all raised to the power of positive 2. So that negative sign there, it actually swaps the top of the fraction and the bottom of the fraction. So that's the first thing that you do when you see a negative exponent. So now let's try to apply that law here. Because we have a negative 2 here, what we can do, we can just swap the top and the bottom of the fraction. So we are going to have x y to the power of 2 all over 1, because the bottom comes top, the top comes bottom, and therefore the exponent will change now the sign to be positive. And the very same thing will happen to this one. So we're going to have y squared coming to the top, then we have x cubed, and therefore the exponent will change now to be positive. So after we have done that, we can clearly see now if we just have a denominator as 1, we can just leave the expression as it is, because any number divided by the 1 is just that number. So in this case, we can just say, okay, so now this is what we have. So the exponent outside the bracket will multiply with the exponent inside the bracket. But you must remember, if you don't have an exponent, you must put the exponent of 1 to that variable. So to simplify this, we're going to have 1 multiplying with 2. So this is going to be x squared, and therefore this is going to be y, and therefore 2 by 2, that's going to be 4. And therefore, when we multiply in this case, this number is raised to the power of 1. That means any number raised to the power of 1, it is that number. So in this case, we still have y squared all raised to the power of x cubed. So now, because we are multiplying in this case, that means the top will multiply with the top and the bottom will multiply with the bottom. So in this case, what we're having is that we're having this thing at the top multiplying with that thing at the top. So in this case, x here is not having a partner to multiply with. So that means that x squared here, we're just going to leave it as it is. We're going to have x squared. And therefore, if you look at y, it is having the same base that it's multiplying with. So it means we need to add the exponent because we are multiplying. So we're going to write the y there, and therefore we add the exponent. So this is 4 plus 2, therefore that is going to be 6. And therefore in the denominator we have 1 multiplying by x cubed, which will just be x cubed. So now in this case, what is just left is for us to simplify again here. So we can clearly see that we are dividing, and therefore these things here, they have the same base. So when we divide them, we need to subtract them. So now, how are we going to do that? We're going to say, okay, so this is going to be x. Since we are dividing, we're going to say 2 minus 3. It is very much important for you to start with the number at the top and minus the number at the bottom. So this is going to be 2 minus 3, which is the same thing as -1. And therefore the y, it is not having any partner to divide with. So we're just going to write it as it is. So this is y to the power of 6. And therefore, we normally don't like to leave an exponent as negative. So what we do, we're just going to move this exponent or this number down so that it changes the exponent to be positive. So the answer in this case will just be y to the power of 6 all divided by x to the power of positive 1. But remember, if the exponent is just 1, even if you don't write it, it is still correct. So now we can move on to do the next example. So now in the next example, let's say for example we have 1 over x plus x over y all raised to the power of -2. So now our laws only applies if ever what is inside the bracket, it is a product. So if it is not a product, that means we must open two brackets if we can. But now, if what is inside the bracket can be made to be one thing, that can be done. So now, remember, we can add fractions. So we can add the fractions and make it to be one fraction. So let us try to do that and see if we can. So now when we add the fractions, the first thing that we do, we must make sure that the denominators are the same. So to make this thing denominators to be the same, we just have to multiply this denominator with y and then multiply this denominator with x. But now remember, you can't just multiply with y and x. If you multiply with y over y and x over x, that means you have not changed the expression since you have just multiplied with 1. And then any number multiplied by 1 is just that number. So now this thing will just change to be what? 1 multiplied by 1, that's going to be y. And therefore we have xy. And the very same thing will happen here. X by x, that's going to be x squared. And therefore we're going to have xy. So now that our denominators are the same, therefore we can add these fractions. So we're going to keep the denominator to be the same, which is xy, and therefore add what is at the top. So we're going to have x squared plus y. Okay, it really doesn't matter how you put your x squared first or your y squared. It just, I like to start with the smallest variable, moving like that to the bigger variable. So I'm arranging my terms in order. So this is raised to the power of -2. So now when we get to this point, we know that we usually like our exponent as positive. So that means we are going to change the sign of the exponent, but when we change the sign, the top comes bottom and the bottom comes top. So now what we will be having is that we are going to have x over y over x squared plus y raised to the power of +2, because after they change, the sign also changes. So now we can apply the law of what? Of distribution. Remember, the exponent, if it is not there, that means it is 1. So these two will multiply with the 1 there and multiply with the 1 there. But now, if you look at what we have at the bottom, we have a plus. So if we have a plus, we're just going to put that and multiply it with this exponent of 1 outside. So now this will be simplified to be what? Remember, this is going to be x squared, y squared, and therefore at the bottom we're going to have x squared plus y all raised to the power of 2. And therefore, if you want to simplify the bottom, we're just going to have x squared, y squared, and then we're going to open two bracket x squared plus y multiplied with x squared plus y. And therefore now to solve that problem, we're just going to say we have what? At the top we have x squared, y squared, and then all divided by, remember you're going to say this multiplied by that, that's going to be x to the power of 4, and that multiplied by that, that's going to be plus x squared y, and therefore that by that, that's going to be plus x squared y, and then lastly y by y, that's going to be y squared. So this whole problem will just simplify to be x squared y squared all divided by x to the power of 4. Therefore we have plus, these are the like terms, so we have to add them. So this is just going to be 2x squared y plus y squared. So this will be the final answer to that problem. So now let us also look at another problems of exponents. Let's say for example we have 227 to the power of x plus 1 multiplied with 18x minus 1 all divided by 36 3 minus x. Okay, so in this type of problems, this is whereby we need to make our bases to be prime numbers. And then for us to be able to make our bases to be prime numbers, we need to know how to use our calculator. So that means in our calculator, what we're going to do, we are going to type the number as it is. So for example, if you look at 27, we're going to type the number 27. So you type the number as it is. And therefore, after you type the number, you're going to type what you call a shift. Before the shift, you type the number and then you say equal. And then after that, you say shift. And then you say fact. And then after that, you say equal. You don't even have to say equals to. You're just going to write that as a particular answer. So let's try to do that in my calculator here. I'm just going to write 27 and then equal sign. And then I'm going to say shift fact. And therefore automatically it gives me this 27 as written as 3 to the power of 3. So automatically when that calculator does that, it writes my number as a base of a prime number. And of which is what I want in this case. So in this case of such problems, we want our bases to be prime numbers. So that is the first step. So in this case, we're going to change all the numbers to the basis of the prime numbers. So the first one of 27, we know this is 3 to the power of 3, and then this is raised to the power of x plus 1, and then multiplied. So for 18, you do the very same thing. 18 equal shift fact, and therefore 18 is the same thing as 2 multiplied by 3 to the power of 2. You write it as it is from the calculator, and then you put all of it to the bracket if it is 2 terms, and then you raise it to the power of x minus 1. So at the bottom, if you look, we have 36. So 36 equals shift fact, and therefore we have 2 to the power of 2 multiplied by 3 to the power of 2, all raised to the power of 3 minus x. So that means our first step is that. The first step is to convert the bases to be what? To be prime numbers. And therefore, after that, we just remove the bracket by multiplying the exponent with exponent of outside the bracket. So now remember, everything will multiply there. So that means you're going to have 3 to the power of what? 3x, and therefore 3 will multiply with 1 also, that's going to be plus 3. So now in this case, remember the exponent is 1 here. And then whatever that is outside will multiply with the exponent of everything that is inside. So 1 multiplied by everything is just going to be as it is. So this is going to be 2 to the power of x minus 1. And therefore for 3, we're going to have what? We're going to have 2 multiplying with x and multiplying with negative 1. So we're going to have 2x minus 2. And therefore the very same thing will happen to the bottom. This thing here will multiply with the exponent of everything inside. So you're going to have 2 multiplying with 3 and multiplying with negative x. So this is going to be 2 by 3, that's 6. And therefore by negative x, that's going to be negative 2x. And therefore for 3, the very same thing will happen. So that's going to be 6 minus 2x. So now, after we are done with the second step by multiplying out, so what we have to do is that we have to look for the same basis. So now, if we are multiplying the same basis, remember, we add the exponent. If we are dividing the same basis, we subtract the exponent. So what I will advise you to do is that you look at the top, if ever, is there anything that you can multiply that have the common basis, and then you add the exponent. Then you also do the very same thing to the bottom. Is there anything that you can multiply that has the same basis, and you add the exponent. And then after that, you're going to look at the division. So you first look at multiplication and you look at the division after that. So now let's look at the top. What we have at the top is that we have 3 as a common base. So now we are going to multiply that. So remember, now when we multiply, we keep the base the same and we add the exponent. So what we're going to have is 3 plus 2x. 3x plus 2x. So that's going to give us 5x. And therefore, we are going to have 3 plus negative 2. So 3 plus negative 2, that is going to give us positive 1. So that means we have added or multiplied these two bases of 3 by adding their exponents. So now the base of 2, it did not have any partner, so we're just going to write it as it is at the top. So it's going to be 2 to the power of x minus 1. And therefore at the bottom, because at the top we started with 3 and there's nothing we can multiply with, we can start at 3 at the bottom also to say we have 3 to the power of 6 minus 2x multiplied with 2 to the power of 6 minus 2x. Okay, so now that we are done with multiplying the top and the bottom, the next step is for us to divide. So now remember, you're going to divide the same basis. So now if you divide the same basis, what you do, you subtract the exponents. So now what we have in this case, our base is just going to be 3. We write it as it is. So now when we subtract the exponent, we start with the exponent at the top. So we have 5 minus negative 2. So you must be careful because it's going to be 5 minus 2. So that's going to give us 7x. So it's 5x minus negative 2, which is 7x. And therefore, when you look at the constant here, we have 1 minus 6, and the answer is just going to be minus 5. And therefore, after we are done with the 3, we're going to move on to the 2. We're going to say, okay, we have the base of 2 here. So we have x minus 2. So if x minus 2, that is going to give us positive 3x. And therefore, we have negative 1 minus 6, and that's going to give us minus 7. So the answer to this problem is just going to be that. So remember, you must follow step by step. So you must do everything as it is done so that you don't make any mistakes. So now we can also have examples such as that, but when we have a plus in between. Let's say, for example, we have 8 to the power of 2x plus 1 plus 4 to the power of 3x minus 1, all divided by 2 to the power of 3x. So in this case, what we have here, it is a plus between our numbers. So we're going to still do the very same process. But now there's a place whereby we're going to take out a common factor because we have a plus. And then if we have a plus or minus, we want to take out a common factor so that we can simplify by cancelling out. So now the very same thing will happen. We first change whatever basis of ours to prime numbers. If you look at this, 2, it is already a prime number, but we can change 8 and 2 to the basis of the prime numbers. So, but now how do we do that? Remember, we use the calculator. You're going to say, just type 8 equals 2, and then you say shift fact. So this is going to be 2 to the power of 3, and then all this is raised to the power of 2x plus 1. Therefore, we keep the sign plus there, and therefore we do the very same thing for 4. Remember, you don't have to memorize them, but if you do memorize them, that is still okay. So we know that 4 is the same thing as 2 to the power of 2, and therefore this is raised to the power of 3x minus 1. Therefore, this is all divided by 2 to the power of 3x. Okay, so now in this case, what we have is that we have to remove the brackets. Remember, this thing outside will multiply with that and multiply with that. And the very same thing will happen to this and that. So now what we will be having in this case, we're just going to have 2, and therefore 3 by 2x, that's going to be 6x, and then 3 by 1, that's going to be 3. Then we keep the plus there, and we have the 2, and then the very same thing will happen. 2 by 3x, that's going to be 6x, and therefore 2 by negative 1, that's going to be negative 2. And then all this is just divided by 2 to the power of 3x. So now, after we do this, so now this is the very important step that is different from the previous problem whereby we just had multiplication. So if we have now a plus in between, we must be able to expand this so that we can look at our common factor. So, but now how do we expand this? Remember, this thing here, it came from whereby we were multiplying the same basis and we added the exponent. So this thing can be written as 2 to the power of 6x multiplied with 2 to the power of 3. So this and that is the same thing. It's just that we have expanded it now. And therefore, we also do the very same thing to the second one. So we're going to have 2 to the power of 6x multiplied with 2 to the power of negative 2, all divided by 2 to the power of 3x. So after we have expanded, we can clearly see now we have a common factor at the top. And that common factor is 2 to the power of 6x. So we're going to take out 2 to the power of 6x as a common factor. And therefore, after taking out as a common factor, we're just going to be left with all this. So remember now, 3 to the power of 2, we can just write it as it is, or you can just put it on your calculator. But now for now, let's just write it as it is 2 to the power of 3. And therefore, we have plus, and then what is left here is just 2 to the power of negative 2, all divided by 2 to the power of 3x. So after we have done that, so what is outside the bracket here? It can cancel out or it can subtract, because now remember we have the same basis, and if we have the same basis, when we divide, we subtract the exponent. So this is just going to be the same thing as what? 2 to the power of 6x minus 3x. So 6 minus 3 is the same thing as 3x. So what is inside the bracket here? I would just advise you to just put it in the calculator as it is, so that you just get the final answer. So now if we put that in our calculator, we have 2 to the power of 3, which is 8, plus 2 to the power of negative 2. And that's going to give us 33 over 4. So if it gives you a fraction, something like that, so that is still okay, we just have to leave it as it is. So now in this case, we're just going to have 2 to the power of 3 plus 2 to the power of negative 2. And therefore, after that, we can just simplify this by multiplying out again. So what are we going to have? We are going to say, okay, this will multiply with this thing here. But now remember, when you multiply the same basis, you add the exponent. So this is going to be 2, and therefore 3x plus 3, that's going to be 3x plus 3. And therefore we have a plus here. Then we do the very same thing. We are multiplying 2 and 2. So we're going to keep the base the same and we add the exponent. So this is going to be 3x minus 2. So our answer will just be left as it is. So this is all that I have in this video. I hope this is a good revision of what we have done in grade 10. So now we are going to continue with the same problems in grade 11. In the next video, we are going to discuss the sets, which are kind of new to you. And then we will be done with this chapter of exponents and sets. And therefore, we just have to do more practice. Remember, if you do practice, more practice, then you're going to get good with all this. Thank you very much.